All right, here are perfect problem 5 solutions. This is the confidence interval problem. So we're given a random sample of 64 basketball players, n equals 64. We know sigma and x bar, and we're asked to calculate a 90% confidence interval. So let's see, we know that alpha is equal to 1 minus 90%, which is 0.10. And what is this for how high people jump, for vertical leaps? I see the answer ends up being this 30.0325 all the way up to 34.9675. Okay, so it's kind of asking, what is the question? What did sigma have to be and what did x bar have to be to make this the confidence interval? So kind of working backwards here. Let's see, so we got two things to find. The first one is a little bit, well, the easier of the two is finding x bar. If you think about a confidence interval, what you do is you take this point estimate, which is x bar, and then you go up and down from that point a given amount, and that gets your confidence interval. What I'm saying is that x bar has to be right in the middle of these two numbers, because we figured out our margin of error, and we added that to x bar to get here, and subtracted it from x bar to get here. So x bar is just 30.0325 plus 34.9675 divided by 2. It is x bar is the number that's right in the middle of these two, the mean of them. I think I made this work out well. If you put this into your calculator, you get 32.5. Okay, so that's this guy. We still got to find this guy. Unfortunately, that's a little bit harder, but it's not too bad. Let's see, the way you would get at this interval right here is you would take, so maybe the confidence interval equals x bar plus or minus the margin of error. So part of the margin of error is this sigma. So if we can figure out what the margin of error is, we can work to figure out what sigma is. So let's see, we took this x bar, this 32.5, and we added the margin of error to get to this number. So if you find the difference between those two, I guess we could say margin of, well, 34.9675 minus 32.5 is our margin of error. Maybe I should abbreviate that in the future. And if you subtract those two numbers, you get 2.4, what is that, 675? Okay. And now the question is, how do you relate that to sigma? Well, let's see, 2.4675. The formula for the margin of error is it's z sub alpha over 2 times, let's see, let's do it this way, sigma divided by the square root of n. So this looks really bad, but it turns out that we have most of this information. So if we just plug in the numbers that we have here, we can solve for sigma. Z sub alpha over 2, alpha is 0.10, so this is z of 0.05. That's saying what is the z-score that has 5% of the area above it. And if you remember from your critical values, that ends up being 1.645. Sigma we don't know, but we will have to figure that out. Let's see, n is 64, so the square root of 64 is 8. And that is all equal to 2.4675. All right, and from here we can solve for sigma. Let's see, kind of running out of room. Jump up here. If you divide both sides by 1.645, you get sigma divided by 8 is 1.5. And from there, multiply both sides by 8, and you get sigma is equal to 12. Nice round number. So that and this are the answers to part 1. Then you move down to part 2. See, we're unhappy with how big the confidence interval is. We want to create a new confidence interval that's half as wide. In other words, the new margin of error. How about margin of error is equal to, see up here it was 2.4675, so half of 2.4675, which is some kind of ugly number. Let's see here, 1.2 0.3375. Okay, but it's still a 90% confidence interval, so z sub alpha over 2 is still the same. Sigma is still the same. The only thing that's going to change is the square root of n. So what we have is this number is equal to 1.645 times 12 divided by the square root of n. Couple things. If you get kind of clever, you might be able to just figure out what n is based on what it was up here. But I'm going to suppose you don't see that and just go ahead and solve this algebraically. So what you could do is divide both sides by 1.645. And if you do that, you get 12 divided by the square root of n is equal to 0.75. So the square root of n, if you multiply that up here and divide the 0.75 down there, is 12 divided by 0.75. Or since 0.75 is just 3/4, 12 divided by 3/4 is 16. So we figured out the square root of n is 16, but that's not what we want. We want to know what n is. So the way you solve for n is you square both sides, and 16 times 16 is equal to 256. So if you wanted the confidence interval to be half as wide, the margin of error to be half of what it used to be, you'd have to increase n from 64 all the way up to 256. And yeah, you could have gotten a little bit clever and realized that to be half as wide, we just need this to be twice as big. So we need the square root of n to be twice what it used to be. So since the square root of n up here is 8, the square root of n down here has to be 16. 16 squared is 256. But that would have been kind of the clever, quick way to do it. Makes more sense after you've already seen the longer way, so here's the longer way. And I guess that's the end of this problem.